All right, so I am recording again, and I am just going to work a few more of these equations. You can work independently at your own pace, but I need to post some video recordings of how to do this. All right, so here I have one thing, and then I have a compound, right? So I know this will be a single replacement reaction. So here I have not listed the elements or ions for you. So I'm going to do that now. I just make a list of everything on the reactant side, and I'm going to keep it in the same order on the product side so that we can follow and compare more easily. So I've got Mg, H, and Cl. And over here, I'm going to keep that list in the same order, even though the ions have rearranged. So I've got Mg, H, and Cl. All right, then I count what I have. No subscript means I have one. Hydrogen, it's in a compound, but still no subscript, that's a 1. Chlorine is Cl, that's a 1. On this side, magnesium, Mg, is equal to 1. Cl is down here now, but it is a 2, has a subscript of 2, and hydrogen has a subscript of 2. So my magnesium is balanced currently, but it's almost certainly going to need a coefficient because I'm going to have to change some of my other coefficients. So hydrogen is not balanced. I need more on the reactant side, so I'm going to put a coefficient in front of the compound with hydrogen. That's HCl, or hydrochloric acid. That's going to be multiplied by 2. And that multiplies the chlorine as well, right? We always have to multiply the entire compound. And wonderful, it's balanced. It's just magic. It happens that way sometimes. All right. So next one. Now we have two compounds. Now it doesn't look quite like as obvious that it's a double replacement reaction. It's probably a subcategory of double replacement. But because we have two compounds forming two compounds, it's not combustion. We're going to call it double replacement. Okay, next thing I do is I list what I have. And I keep the list the same order on the product side. That's important so you can make those comparisons. Keep your list in the same order. And then I count. I make the list first when I get to the product side so I don't get confused. So Ti is equal to 1, O is equal to 2, H is equal to 1, and Cl is equal to 1. I compare. My titanium is balanced, my chlorine is not. And if I want to increase the chlorine, I could put a 4 here. That's going to increase the hydrogen, and I think that should work out. Let's see. So I'm going to put a 4 right here. That's going to multiply Cl and H. All right, now I compare again, and I see that I need to increase the amount of hydrogen, so I have to put a coefficient in front of the water molecule. I'm going to put a 2 there to multiply the hydrogen by 2. And that will also multiply the oxygen by 2, which is perfect because now it will be balanced. And that's the thing. These equations are designed to be balanced. They will balance. And so you just have to follow the process. Okay. let's see. Let's look at a more traditional double replacement reaction with polyatomic ions. This one's a really traditional one that you'll see. You've got two ionic compounds. They're swapping partners. So again, two compounds on each side. This is double replacement. That's how we know. Then I'm going to list Ag, silver is equal to 2. When I list my polyatomic ion, I'm going to keep it all together. I put parentheses around this one, even though I wouldn't really have to because I have one copy of it. So when I'm doing polyatomic ions, I'm looking outside the parentheses, or you may see them without parentheses when you have only one copy. All right, Ca is equal to 1, and Cl is equal to 2. So we go over here. We've got list in the same order. And then I will count. I've got 1 silver, 1 chlorine, 1 calcium, and 1 sulfate. I'm going to need to increase the amount of silver on the product side, so I'll put a coefficient in front of silver chloride. And that will multiply my chlorine, and my equation is balanced. So the key there is just knowing how to count the polyatomic ions. So if they don't have, so when you have a single polyatomic ion, it may not have parentheses after it. So for my honors students, I don't always put those. But you should be able to recognize them as more than one nonmetal grouped together as the second part of an ionic compound. You never use the subscript inside the parentheses, except you saw what happens when we get into the really hard reactions. If the polyatomic is not on both sides of the equation, then it's a whole different thing. But here you can see it's kept together. It's identical on both sides of the equation. So you are going to keep it together and just keep track of how many copies you have of that polyatomic ion. And if there's no subscript outside of parentheses, then you have just one copy. All right, next one is pretty straightforward, so we're going to stop there, and I'm going to go on to